asked me about importing files from, in his case, SolidWorks. So I'm going to go through that process. He saved them as a DXF, and that's what we'll import. I would typically go to open an existing file and just grab the DXF. I've got it saved under his name, so I'm going to stop recording for a second, grab the DXF, and then start recording again, so that we can keep things separate. And I'm going to make this a generic drawing, so I'm going to take off his company name and the name of the products and the production part name and things like that, just so I can use this video, hopefully, generically as an instructional video without company information still showing up on it, with his permission. So I'm going to open an existing file, and I'm going to stop recording, open it up, and then come back and show you what I'm doing to delete information. So here we go. Okay, so I hit the DXF and it came in full screen. I scrolled out, so we're getting rid of, we can't see some of the clarity of it. And then as soon as I hit OK, it pops it in full screen again, so I had to edit that out. And what we're going to do is I'm going to take out the title block, so I just select it and take it out. This bottom line had information about the product. This last line of the instructions, and that shows the part number. I'm going to scroll in just a tiny bit just to be able to get it. So that had the production number. And this says production notes, and there's information about, I can scroll in at this point. There's some holes that are going to be drilled. It's a 0.17 hole going 3/4 of an inch deep. There's 28 of them. There's a dado here at the back, and a 0.13 radius on the corners. So basically, that's all I need to know. All the other information I don't need. But what I'm going to do is I'll do another capture, and then Control C, Control V, and then just drag it out away from where I need to work. And that way I'll have a reference here, but I can get rid of everything that I don't need. So what I need to do is get this thing scaled properly. So I'm going to grab the parts that I need, and this is, from this corner of this part to here is 29.875. So I'm going to grab the parts that I want to get, and that would be this part and this part. I'm holding down the Shift key, and you see the fillet is not joined together, so I need to select that as well, and then I can use my join command. And right now there's 3 pieces, and when I finish using the join command, they're just 1. So now if I select this, it goes all the way around, but it's not going to grab this line. I'm holding down the Shift key, or this line. I'm going to come back in over here and grab this and the fillet. And at the bottom, I can create these by extending the lines. There's plenty of commands to do this. And that's all 1. That's good. And then all the circles. So I'm going to now select everything that I need to scale. And I'm going to come with the height of this piece. And I'm going to get these selected circles by anything that I fully capture. Left to right, top to bottom will be selected. And that means the circles. I'm getting some of this line. I can touch it again to unselect it if I want. And I'll get these as well. I had a message come in that I killed. And I don't want that dado as well. I'm having a text message thing pop in on the bottom, so I'm editing that out. I've got those. I don't have these. I've got those. I'm just checking it real quick. All the drilling operations. I've got the 28 drilling operations. That's good. Okay, so now I'm going to take that and I'm going to scale it. And the height of this overall is the perimeter of the piece, which was the 29.875. So I'm going to change the scale. And in the height, in the Y, I want to change it from this to 29.875. Well, no surprise. That's exactly 400%. This is 1/4 inch to a foot. So that'll make this transition. If that's the way these drawings are always saved, I don't worry about it. Just change it to 400% and link X and Y, and it will resize everything. I don't care about all these other lines and extraneous dimensions and stuff. I don't need them. So I've scaled up what I need to do for production, and I left the other stuff there. And I'm just going to capture all that and delete it because I have a copy of the entire drawing over here. Got some extraneous lines that I grabbed by mistake, so I'm going to get rid of them. Don't need this. Now, if these had come in on layers, when I imported them and the dimensions were separate, the text notes were separate, the title block was separate, then I could just bring in, operational parts. I could have just turned those off and on through layers. So this can change how you do stuff on your design end too. If you want to do some of the work there and layering, it can cut down on the work that you're doing on the toolpathing side. So again, this is simply for me to be able to work from later if I need to look at some dimensions or check anything. I'm just going to grab this and move it further out just by holding down the left key. Just to get it out of the way of the drawing. And then I'm going to resize. And I don't know what size panels he's using. He's cutting these tops out of, this is the bottom side of a top. And he cuts them out of resin. So I'm going to go back into my material sizes. And I'm going to say this is a 48 or 49. I'll just go 48, 96, but it could be 120 inches. It could be longer than our table setup. And they are 1 inch thick. And I'll tell it okay. So that's our material, and this is the drawing that we imported. I'm going to highlight everything and rotate it 90 degrees. And then I can position it where I want to on the table. Doesn't really matter. And I'm ready to do some tool pathing. So I'm going to jump over. This is, if you're not familiar with VCarve, the way I use it, and you can have both of these sides turned off and on at the same time. I prefer them not. I do all my work with getting the drawing and the vectors right, and then I flip over and turn the design end off and just go to the tool pathing side. So at this point, I'm going to grab all the parts that need to be drilled. So I'm just going to hold down the shift key, and I've got those, and I've got these. I'm zooming in and out with the scroll wheel. I've got these. I've got these. I see I've got a little straggler here. I don't need this. That was an extra line that denoted how deep these holes were. I'll delete that in a minute. So all these are going to be a drilling operation. So I'm going to come in and do a drilling operation. That was a 0.13, I think, hole. So I'm going to use, and the cut depth was a 1/4 inch. I'm going to use an 1/8 inch end mill. When I was editing it, I saw that I had said this was a 0.13 hole. It's not. It's 0.17 as specified. So again, there's different ways to do it. I can pocket all the way through it, or I can have the proper size drill bit and go down in one punch or do the Pec drilling and things like that. So this little bit was just added into the video because I saw my error. I had said it was 0.13 using a 0.125 bit, and it's 0.17, and I had selected a 0.125 bit. Bit selection is important, but so let's move on. If you haven't seen this before, this is how you select your tool. Go to select, click the button, your tools drop down. I'm going to use an 1/8 inch mill and just select it. And I'm going to do Pec drilling where it's coming down a certain amount, and then it retracts a little bit to help get rid of the swarf, and then goes back down to do the rest of it. And we had set a 0.75 depth of cut, and you can set this up. Do I want to retract above the material? Depends on the material you're cutting, whether you need to come all the way out to clear it, or if you just keep going down, if it's going to keep spiraling out. We're going to probably use a spiral O, and that'll do a great job on resin and make it fast. Do we want to dwell at the bottom to help clean out or not? So I'm just going to call this drill holes and calculate. And we're done. I'm going to turn on the 2D view. I'm going to get in there and get that little tab that I don't want. Okay, I'm going to come in here and get rid of this tab. This mark here. That was to annotate the depth of cut. So the way this is set up right now, I'm drilling. So I'm just doing a direct drop of the bit into that hole. I don't know if that hole needs to be machined the full 0.13 or an 1/8 inch bit's going to be right, or if we just order a 0.13 cutter. All of that can vary. I can also do this as a pocket where it comes in and it spirals down with a standard 1/8 inch bit, and we'll come to the edge of this vector of each of these holes and spiral down and cut it. It doesn't matter. We can handle it with standard tooling. They may already have a 0.13 bit already made. Doesn't matter how we get there. It's not a problem. So I've got that. I'm going to zoom out, and I want to do my dado here. I don't recall how deep this is. I'm just going to make it a 1/4 inch. So I'm going to take that, and I'll do this as a pocketing operation. This could be the same way we did the drilling. I will use the same tool. I'll do a 1/4 inch depth of cut. I'm going to switch my bit. This was from it saves the last one we used. So I'm going to go right back in here and select the 1/8 inch end mill. And that'll be 2 passes in depth. And do I want to ramp it in? Yes, I ramp it in over, say, 1 inch. That means that when I come into the material, I don't just drop straight down. I come in at an angle over the course of 1 inch for each depth of cut. And I'll call this pocket for the dado slot. Oh, just typing. And that's that. And so the next step would be to do the border cut. So I'm going to take this whole border. If I look at it, because I joined it, it's all there. And I would do a profile cut. And in this case, I want to go the thickness of my materials. That's T plus 0.020, so 20 thousandths of an inch into the spoil board and tell it OK. And I want to select what tool I'm going to use. I could do it still with the 1/8 inch tool, but that'd be a lot of passes. I may, depending on the production needs, I may want to go instead to a different tool and cut it at a faster speed. Speed being off the table. Because if I use a 1/4 inch spiral O, I can probably do the full radius of the bit, the full diameter of the bit in each depth of cut, and I can do this in 4 passes. Plus, I'd probably do a finishing pass to take away the witness lines of each of the depth of cut changes. You may have a polishing operation that will take care of those, and I can eliminate the final separate last pass, but I'm just going to do it this way, and I'll do a spiral O 1/4 inch and 1/4 inch depth of cut, and each time will be fine, but I'm going to do a separate last pass of 25 thousandths. So what that will do is the first 4 passes to go all the way down, it's going to be overcutting. This is my material. It's going to be overcutting them 25 thousandths of an inch, and doing that allowance at the bottom as well. So the final pass is going to come in that 25 thousandths, and that way the entire bit is going to be cutting the material and get rid of those witness lines from the drops in the depth of cut. If this is resin, I probably don't need to do any tabs. It's heavy enough that it's not going to move because it's the whole sheet while I'm cutting it, and I'm leaving that skin at the bottom until I cut, and then I'm just barely cutting that in this case 5 thousandths, because I'm doing 20 thousandths into the spoil board, so I'm just barely cutting it free and barely touching the side of the material to clean up those witness lines. I do want to do a ramp, and that can be a smooth ramp. That's fine. Over 1 inch, that's fine. And so I would call this profile cutout. It warns me that the depth of cut is deeper than the material. That's right. I'm going to go into my spoil board, and I'm good. So I'm going to reset the preview, and then I'm going to slow this down, and we'll preview all tool paths, and it'll do them in the operation. So it'll first do the drilling, then it'll do the dado, and then we'll have a tool change, and it will do the perimeter cut. So we'll preview all tool paths, and it shows, you can barely see it, but there's it's drilling the holes. And if I had zoomed in and rotated stuff, we'd see the tool itself. I'm going to cancel. Let's do that. I'm going to rotate a little bit, reset the preview, preview all, and we'll see the tool moving around, popping in and drilling, doing the Pec drilling. Again, depending on the material and the bit, we may not have to Pec drill. We may be able to just plunge right down there, and we can set the plunge rate, how fast we're going down into the material in that tool database. Wherever I selected the tool, we can change the rotational speed of the drill, or the router cutter, the inches per minute that it will move through the material in the case of the dado and the border cuts, and the plunge rate going down into the material. I'll speed this up now. It's starting the first pass of the perimeter border cut. So that's one, and again, we did this in multiple passes. I'll just go speed it up. And then the final pass. And then if I click on any part that's free, now I can zoom in, control, and there's my holes. The resolution of the screen, you can change that to extremely high resolution and things like that in the setup over on this other side. I can show you later. That's in some other videos, but this is what you see is what you get. That's it. So we're ready to go. At that point, you got to decide how you're going to do this. If we look at the machining times, and we're going to be, that's probably about right. The border cuts, I can probably cut at 150 inches per minute with a 1/4 inch depth of cut with a 1/4 inch spiral O is my guess with most resins. But we'll just leave it at this. So we're saying 15 minutes per with Pec drilling. Who knows? I would just print this out. So I would just try this on scrap material, see what the Pec drilling works like. If we have to do Pec drilling, if we do no Pec drilling and just go all the way down, if we do pocketed holes to get that 0.13 with a 0.125 bit, or if we're using the proper size bit to do it in one drop, again, it's all varies based on the tooling that you have and the setup that you want to go with. The machine's going to be able to do it. So I've got everything done. At this point, we're ready to send it to the machine. Basically, if we hover over on top of the drilling operations and the pocket both use the same tool, and then we're switching here to a 1/4 inch tool. So if I was doing this for production, I think what I would do is probably not do the tool change every time one of these is on the table. I'd look at my production for the day, and I would cut them first. I'd swap the profile cutouts first, and I'd put the full sheet on there, cut it, put another sheet on there, cut it, put another sheet on there, however I need to do it to get, and I would cut the profiles out first. Then I would put them in on an indexing jig, jam them over against the jig, and then do the drilling operations and the dado. Because if we look at the timing, the drill and the dado takes 7 minutes roughly, and about 7 minutes to do the profile cutout. Who knows? We'll play with that based on how the material is responding to the operations. So at that point, we're ready to go. I'm going to take the profile cutout and save that to the machine. And I've already done this, but my audio wasn't set right for the microphone volume, so I'm redoing the movie. So I would save this toolpath, save the selector one with the 1/4 inch end mill, save it. And here's how I name them. Okay, I cut off the video for just a second because it was going to the wrong directory. It was going to a customer names directory, so I keep a generic directory here. So the way I would name that is I would name that EJS. Say the job is EJS resin job. This is the first toolpath I'm going to do, and this is a 0.25 spiral O profile cutout. I want to make sure I've changed it here and highlighted this so it changes the tool, and I'm going to combine those two together. And I would do it the same way. I'm just going to highlight it. And this will be the EJS resin job. And this is the second tool path. And this is a 0.125 spiral O. So I'm looking at the monitor at the same time. And this is drilling and dado. So the way I do it this way, so that if I design this in the office one night and then I send it to the shop floor, and whoever's working on the shop floor, they'll be able to see the job name, EJS resin, tool 1 and tool 2, and what the tool is and what the operations are. So even if I don't print out a full job sheet, which we have the availability to do in VCarve, they have everything they need to look at to run the job. So the job sheet is interesting. That's this. And I'll just send it there. And I'll rename it EJS resin job. And then I'll open that. I'll probably have to edit some of this out. Okay, so I had to edit it so that I came into it generically and not showing a bunch of customer names. And so this is the EJS resin job. And what this is a quick overview, and it doesn't show up on screen, but it does a printout of what we're doing. That I'm touching off on the top of the material, on the bottom left corner of it, what materials I'm using, how long it should take to cut the job, the way I've got it set up. And again, if you print these out and run them out to the job, they can make any notes. Hey, we didn't have to do Pec cutting. It was doing a great job getting rid of the debris, and the swarf is coming right out. Let's try it without Pec cutting next time. So any kind of notes that they want to hand write on there, they can do. But this gives them a good idea of what they're doing. And there's a drawing that will show up here of the entire process. And it's got a small part of the drawing here that I imported as a DXF with all the dimensions. You're not really going to be able to see it. But if I printed out the job here in VCarve, I can zoom right in and print preview and print that out if they needed it. Again, they shouldn't, because we're doing all the design work up front. At that point, it's ready to go to the machine. Again, I've already sent this, so I'm going to refresh, hit the right button and refresh this. And I'm just going to send this out generically. I'm going to go to the machine. I'm touching the machine side now, and I'm going to delete them from the console. So they are no longer on the machine. And I will take the new jobs that I just designed. EJS resin job. Tool 1 is a 0.25 spiral O. It's going to do the profile cutout. And tool 2 would be a 0.125 spiral O for the drilling. Now, if I was doing these one tabletop at a time, I would reverse these. I would have the full sheet down, do the drilling operations, do a tool change, and then do the cutout. That way I'm using the entire weight of the whole slab to hold everything down while I'm doing the drilling. If I'm going to do these in quantity, I would set up and I would cut multiples out first and then index them and then run just the drilling operation and not have to do a tool change on each part. I'd cut all of the table sizes out with the radiuses, all of them that I'm going to do in a given production run, say in the morning to lunch or whatever, and cut out 15 tables, and then re-index them onto a common point on the table, and then do all the drilling operations, and just do one on, put one on, drill it, run that same program again and again and again. And that way I can let the thing run a little more unattended than working 7 minutes, having to do a tool change, another 7 minutes. Take the panel off, I can go 7 minutes without having to think about it and just cut all the panels. It depends on how your workflow is going to work in your shop. It's entirely up to you. But so I've just grabbed them. Dragged them over here, and the transfers are finished. They're on the machine waiting for me to send my operator and say, hey, go run the EJS resin job. It's going to be two tools, and off you go. I hope that video was useful for you. I sell and support Yeti SmartBenches, and I sell and support VCarvePRO and Aspire, any of the Vectric products. So if I can help you in any way, give me a call at 205-871-6618. That's 205-871-6618, or fill out the contact page at YetiSmartBench.com. I've sold and supported more smart benches in the U.S. than anyone else, and we know the machine inside and out. Thank you for watching the channel.